So we're going to talk about the global infrastructure, talk about the data centers, describe the benefits of some of the global infrastructure, and then compare some methods for provisioning AWS services, just so you know, like the types. Now, at this point, you should see the slide forward. So if someone's not seeing that, please let me know. Cool. All right. Okay. So let's say that someone's trying to get to like our coffee shop, but it's blocked off because someone's having an epic party. And while we're not joining the party, we still want coffee, right? So what would happen is that we would redirect people to other locations that might have the exact same coffee. I know this sounds a little bit like Caribou Coffee or Starbucks or Tim Horton or whatever you're using, right? Now, let's explore the physical infrastructure. Now, one of the best ways to do that from my perspective is to actually just look at an AWS global infrastructure map. So if we go look at Amazon's global infrastructure, one of the things that you should take away from this is that this is where all of their like clusters of data centers live. You might say, what, Michael? That's weird. What are you talking about? Clusters of data centers. How come we're not just talking about data centers? And the reason is like, for example, up here is they're coming up with a Canada West kind of like cluster of data centers. And again, you're like, Michael, that's a confusing term. It's not meant to be confusing. What's happening is, for example, this is Northern Virginia. Northern Virginia is where AWS was birthed. This is the first physical data center that AWS had. This like region, if you will, is actually comprised of 6 clusters of data centers. So it's like a meta cluster, but they're not all geographically near each other because honestly, that would be silly. Because if there's going to be like an outage, like a power outage, you don't want everything on the same power grid. You don't want everything, all the data centers to all using the same internet provider. You want them to be far enough apart that the power grids are distinct. The internet service providers, maybe those are distinct as well. In other words, everybody has their own cable. So notice this says, and I want you to ignore local zones and ignore wavelength zones, but availability zones, it says there's 6. These 6 clusters of data centers, they make up the region of Northern Virginia. If we go look, for example, at Oregon, which was launched in 2011, Oregon has 4 availability zones, which means there's 4 clusters of data centers that make up, that are in the Oregon region, and they make up this region. Now, these availability zones are sometimes referred to as AZs, and these regions are sometimes referred to by these special codes called region codes. If we go back to the EC2, like the web console, if you look, notice in the upper right hand side it says that I'm currently residing in Ohio, which means that if we go back to our infrastructure map and look at Ohio launched in 2016, it has 3 availability zones. That means there's 3 clusters of data centers inside the system. This is known as US East 2, US-East-2. If I want to get into a specific cluster of data centers, I have to put a letter on the end of that and call it US East 2A or US East 2B or US East 2C, right? 1, 2, 3, ABC, right? not the song. So just know that all over the world, Amazon has these regions that have clusters of data centers in them. And at a minimum, there's at least 2 clusters of data centers inside each region. Sometimes there's 3. As you can see here, Oregon and Virginia are exceptions. They have 4 and 6 clusters of data centers. That's not common. Amazon's not doing that anymore. They usually try to get everybody to 3 clusters of data centers, so that like if you're in Mumbai, for example, and you've got 3 clusters of data centers, if one of the clusters fails, the other 2 stay up. Right? If you're in Germany and one of your 3 clusters fails, the other 2 stay up. If you're in Tokyo and one of your 2 clusters of data centers fails, the other 2 stay up. In general, when AWS has a failure, it's in a single availability zone. Now I say that, Amazon had one of its like 2 or 3 global out. It was 2 global outages in the span of as many days. That's unusual, actually. They haven't had anything like that happen for a while, but it does happen. So I feel like half the internet was down because they were down. Regardless, just know that that's a very much a rarity. And Amazon does, ask that you design for failure, especially from either a region to region failover, but mainly within a region, they ask you to use 2 or more availability zones. It is bad practice for you to be in a single region and only use 1 availability zone inside that region. They do not recommend that. They ask that you use 2 availability zones because that gives you 2 clusters of data centers to use. So keep that in mind. Now, this is Amazon's like core infrastructure. Regions, which are comprised of availability zones. Do note that Amazon also has these things called edge locations. Where are these at? They're also known as points of presence. Amazon recently took down their maps of this. I'm not sure why. So bear with me just one second. So Amazon used to have a great interactive map like this, and they took it down recently. Oh, it's on the, oh, there it is. It's on the blog. So just know that this, so in addition to having their regional locations, Amazon has servers. These are not data centers. Let me be clear on this. These are not data centers. These are either server clusters or single servers that are scattered all over the globe. Here's the genius. And I don't know if Amazon like incepted this or if they just copied somebody else. I suspect that Netflix and them kind of partnered on this whole thing. Is that they put servers or racks of servers near every single major ISP, near every like dense population center. You may think, Michael, why is that genius? Who cares? Because what this means is that they now have a caching server at every single like ingress where users like come together around internet. This allows them to do things like cache websites, cache DNS. They can do all kinds of interesting like performance improvements because instead of having a data center in every single like location or every single city, they've got a bunch of servers there, which is not their data center, it's probably somebody else's. And that location now acts as a caching mechanism to speed up your website or to speed up your application. So these are called edge locations or points of presence. And Amazon has them like all over the place. So not only do they have them every time they have a region, but they've got tiny little servers just sprinkled all over the globe, right? I actually had a guy a couple weeks ago from AWS in my class who was an installer for these locations. And he was like, yeah, we've got like 300 of these things, probably more. Know also that, like they've got them in Atlanta, they've got them in Dallas, they've got them all over the place. And their job, the job of these edge locations outside of the core network is to help speed up the user experience. That's its job, its function. Now, I would be totally remiss if I didn't point out that they also have other physical locations, local zones, wavelength zones, but I just want to tell you that's way too advanced for Cloud Practitioner. Just know that you need to know that regions are comprised of availability zones and that Amazon has points of presence, also known as edge locations, scattered all over the world. They only have about, by the way, 30 regions that are pending in 2022, right? Obviously it says 26 launch regions. They got like 30, like they got at least 4 more pending. The regions are the real powerhouses. This is their data centers. This is where they run all the core services. The edge locations are also known as the points of presence, of which this is listed over here, where it says 310 points of presence. Those are just servers or racks of servers, and they're only used for caching or for DNS resolution, okay? So just know that if you're gonna run your application, you're most likely gonna run it inside of an availability zone, inside of a region. But if you need caching, you're gonna turn it on, and those points of presence are gonna come into play as well. Those are the 2 big pieces of infrastructure that you really just need to be aware of, okay? All right. Now, how do you select a region? You're like, Michael, that was awesome. Good. I'm so glad that I've got Virginia and Tokyo and Oregon. How do I know which one to use? Well, first of all, check your security compliances. Because if you're a US company doing business with the government, probably not going to run yourself stuff in like Beijing, for example, or Shanghai, right? Just know that like where your customers at. If your customers are located in Japan, which that would be fun, it would be actually. Just know that you probably want to be in Tokyo or Osaka. You don't want to, be in the United States. That's weird. Why would you cross the Trans-Pacific? The other thing is that you're like, hey, we only use cutting edge Amazon services. Well, guess what? Cutting edge services are really only released in either Oregon or Virginia. So because that's where things get started. So you're going to need to be in one of those two locations. For example, if you want quantum computing, I don't think that runs everywhere. I think that only runs in Oregon. So like you need to like pay attention to what your service availability is. Last and not least is pricing. So like, for example, most people avoid the Northern California region in the United States because it's about 10 or 20% more expensive for the exact same workload compared to Oregon or Ohio or Virginia. So you probably might want to avoid Northern California in the United States. By the way, every single continent has a region that seems to be way more expensive than the other regions. Like I think it's Germany and Europe. It used to be Tokyo in Japan, but that seems to have normalized for some reason. So just know there's a variety of factors as to why you might choose one region to host your apps over another. A reminder, a region is comprised of data centers, clusters of data centers actually, called availability zones. So just be aware that when you run anything with a network card, it has to live in an availability zone. Because remember, network cards have to have an association with a physical location for the most part for them to function. So you can't just abstract that away. So if you want to run in Oregon, you got to choose one of the data centers, one of the availability zones in Oregon. If you want to run in Ohio, you got to choose one of the availability zones in Ohio. If you want to run your virtual machine, you can't just like abstract it away. By the way, remember this best practice. If you're going to run a web server in production or an application server in production or a database in production, you must span 2 availability zones in that region to meet Amazon best practice. If you don't, your risk of failure is way higher. So just know they want you to run 2 web servers and 2 application servers and 2 database servers that are talking to each other and syncing each other. Because otherwise, if there's a failure in one availability zone, it's going to cause an outage for your app. They don't want that. So let me ask you this. Which of these is bigger? Regions or AZs? That's right. Which of these is where you're going to stick your actual virtual machine because it has a network card in it? Regions or AZs? So remember, regions actually kind of like don't exist, right? So it's going to be AZs, right? Because remember, regions are comprised of AZs. So there really is no place for you to stick it other than an AZ. You have to stick it in an availability zone. That's really your only option. And please don't get me wrong. There are a bunch of serverless services that operate at the regional level, and you don't have to stick them inside of an availability zone. But remember my caveat. If you start something with a network card, like an operating system, it's got to run inside of an availability zone because it's got to have networking information. Okay. If I want to turn on caching, am I going to run in an availability zone, in a region, or in a edge location? Which physical infrastructure am I going to be running on if I turn on caching? That's right, Grace. If I turn on caching, I'm going to be at the edge. So there's going to be either what they call points of presence or edge locations. Good. All right. I said this before, is that on average, how many availability zones make up a region inside of AWS? Good. Good. At a minimum, they typically run 2, like when they first launch. Eventually, Amazon gets it to 3, but 2 to 3 is probably the best answer. They never run less than 2. They won't launch a region with just 1. Yeah, so all the edge locations are basically places where Amazon runs caching, or if they're trying to like, do like network acceleration, they'll do that at the edge locations. Remember, the edge locations, there's like 300 of them, whereas there's only 26 live regions in the entire world. There's 300 racks of servers that Amazon has placed strategically all over the world, and those are used for caching and or content acceleration. So that's what the edge locations are for. So DNS resolution. And you can only in regions. Edge locations are just for the enablement of other services, smaller services. All right, let's say you want to get closer to your customers. By the way, this is where the edge locations come in as well, is that let's say you're like, I want to share the goodness of our coffee with the entire world, which sounds like somebody's already done that. What you would do is you would put a copy of your coffee shop in every location that really wanted it. By the way, this is no different than how the CloudFront delivery service works with those edge locations. Here's an example. Let's say you got a customer in Russia, as an example, and they want to access a video file that's in Brazil. Instead of having to travel all the way back to Brazil, what they do is they go to the closest edge location. Let's say the edge location is in, Mumbai, for example. Would that be the closest location? It might be, depending on where they are in Russia. So what happens is that they're going to go to that edge server, and that edge server is going to go over AWS's high-speed backbone, and it's going to go talk to Brazil, bring back a copy of the video file, and cache it in that edge location, and then feed it back to the customer. So even if it's the first time that video file is being loaded up and it misses cache, it's still going to be faster because it's going over AWS's backbone. So notice that the second, third, fourth, and fifth customers who go to try and get that file, they're going to have a faster experience because the file is going to be at the edge location. It's not going to require them to go back to the source. Now you might say, Michael, but wait, what if I change the video file? How do I get the cache to kind of let that go? Oh, well, just set an expiration timer, right? Just say, hey, this file is only good for 60 seconds. And then I need you to go back to the source. So this is how CloudFront works with the edge locations to deliver content closer to the users. Now, that's using the edge locations. Just so you're aware, AWS will allow you to actually take the coffee shop and run it in your house. You're like, what? Like, oh, that doesn't make any sense. I'm just kidding. It's in your data center. So like, for example, if you actually want to run a copy of AWS in your data center, they have a product called Outposts. An Outpost, Amazon will literally install a rack of servers inside your data center, and those servers can either be managed locally or they can be part of your AWS account. You can run things like RDS and EC2 instances and EBS. What else can you run? There's a bunch of things you can run on premise, but this allows you to run their hardware inside of your data center. It's called Outposts. So that can be fun. I haven't done that because nobody I know wants to actually take on, like, replicate Amazon's infrastructure in their data center, but there are good use cases for it. By the way, why do we care whether or not we're close to our customers when we choose a place to host our applications? Why do we care about that? What's the holy grail that we want to protect when we make those kind of decisions? That's right. Speed. Well, we want to protect the customer experience, right? You probably know this, but with especially with the like latest generation of like, you know, kids, 18-year-olds, 20-year-olds, if you take 3 to 5 seconds to load a web page, the abandonment rate is ridiculously high. So they're not going to put up with that. They expect less than, you know, sub-second basically response times. So if you can't provide the speed they're looking for, they probably won't even use your app actually. So making sure that your like application is physically close to your users is actually still important. Now, just a review, right? We've got a customer. Let's say that customer is in Sao Paulo, and they are talking to a region that's in Brazil. That region, by the way, is made up of availability zones. And notice those codes: South America -East -1A -B -C, because those are the availability zones that are part of the SA East -1 region. Right? So that makes up the region, is those 3 availability zones. In addition, there are edge locations in Brazil. Well, not Brazil, in Peru, Uruguay, everything. Paraguay. They're all over South America, and they act as content caches for content that could be, for example, in Sao Paulo, could be anywhere else. So just something to keep in mind. This is how the global infrastructure works. You've got regions which are comprised of availability zones, and then you've got these edge locations scattered all over the world. Last but not least, just know that there are 3 key ways to interact with AWS, right? For example, if they're like, say here, like you could order a cup of coffee, you could ask for a refill, you could check your rewards balance. How would we do that in AWS? Well, here's how it goes. You just saw the AWS web console, also known as the management console. You can also do it through a command line utility. It's called the CLI. It starts with AWS. And you can also, by the way, if you love Python or TypeScript or whatever your favorite language is, you can also just use that. Now, you've already seen the console, so I'm going to avoid necessarily a demo of it. But just as a quick refresher, this is where we were earlier when I was trying to launch something. And actually, let's go to the console home. If you want to see all the services, by the way, that AWS has, woof, it's a lot. Don't worry, you don't need to know all those. That's not what you're here for. You're just here for like 20 of them. They're on the left-hand side. That's it, right? S3, some databases, maybe some migration stuff, but that's it. Like for the most part, it's pretty straightforward. If you're ever looking for anything, by the way, you can just type it up front. Let's say you're looking for CloudFront, which we were just talking about. Let's say you're looking for EC2, which we were just talking about, right? Let's say you're looking for SNS, SQS. Just type it up top and you get there. So this is one way to do it. The other way is that you can use the command line. So random theme. There's an AWS command line. So let's say you can do EC2 describe instances, which by the way, I don't have any instances in US East 2 because you just saw me in the console. There's nothing listed there. But like, you know, you can do stuff like oh, come on, Michael. That's funny. For example, this identifies me, like what user am I talking to AWS as? And you can see that I'm as Spartan Sage because I have some authentication information on my local system that identifies me to AWS as Spartan Sage, which is what my son calls me. So I just use that as a username. So you can actually use the command line, or you can actually write code to just programmatically interface with AWS. There's lots of different ways to do that. I'm not going to show you that because that's well beyond the scope of this class. But yeah, so that gives you an idea of like the 3 general ways that we can access AWS. All right, we're going to do a knowledge check and then we're going to break for lunch. Then we're going to be done. Which of the following is true for AWS's global infrastructure? A, B, C, or D? That's right. A region consists of 2 or more availability zones. Well done. That's good. So true. right? Remember, regions are comprised of availability zones. They make up an availability zone. Perfect. Good. So which of the two factors down here should be considered when selecting a region? And just to be clear, service availability and pricing are missing out of this list. So what are the two options that we should be looking at if we want to choose a region? Good. A and B, exactly right. Are you complying with your legal compliances or security compliances? And how close is this data center to your customers? Because it needs to be close. Excellent. Good. All right. So which of these statements best describes what CloudFront does? What is that whole thing with the video file and it being, copied and like, what is that all? What was all that about? What is CloudFront? Then don't get it confused with Outpost. Remember, Outpost allows you to run hardware in the data center. What was CloudFront's function? This one might be a little harder because the answers, but it's actually a global content delivery service or content delivery network. It's also known as the CDN. Fastly, Cloudflare, Akamai, these are all CDNs. There's tons of them. CloudFront is AWS's native cloud global content delivery network. So just be aware. Which site does CloudFront use to cache copies of content? So what is the physical location that CloudFront uses to cache content? Remember, I said this repeatedly. It's like, which of these physical locations does AWS use to cache content? Good. Yeah, the edge locations. Perfect. Okay, last but not least, maybe. Which actions can you perform with AWS Outposts? What does Outpost do for you? Now remember, Outpost's job is to actually basically run hardware, but what it does is it extends AWS's capabilities into your data center. Right? So Terry, yes, good. So C, right? That's it. Perfect. Good. All right. So what we did is we learned about the three core facets of AWS's global infrastructure. So edge locations, availability zones, and regions. We talked about the four factors you want to think about when choosing a region. And then we did talk about Outposts and CloudFront a little bit. And then also the three ways, either through Management Console, which is the web interface, command line utility, which is the AWS command line utility, or programmatically using your favorite language of choice and what's called a software development kit. So those are the three ways to interact with AWS. Remember that AWS is API-driven, software-defined infrastructure. So when you want to scale, you're not going to use the web console. You're going to either use the command line or some tool that allows you to programmatically interact with AWS. So just keep that in mind. All right, it's 12:06, which is like 1 minute past when I usually like to stop. So it's 12:06 right now. So before we close out, does anyone have any questions at all about anything we covered? I promise you will not lose lunchtime if you ask a question. Okay. So it's still pretty close to 12:06 right now. So let's do this. Let's come back at 1:06 in exactly 60 minutes. I'll actually put a timer up in case you forget. It's 1:06. So come back in 60 minutes. Let's come back here. We're going to continue on. We're finished with module 3. Thank you so much for participating, and have an excellent lunch. Please step away from your computer if you can, just to give your brain a break. And we'll see you in about 59 minutes now. All right. Have a good one, everyone.